Okay, this was a 2014, and in 2014 was the first year of that was the first year where the test was reconstructed. I'm trying to think of the word I'm looking for, but it's a first year of the test revision. And so what happens is the first um, three questions are long, 23 minutes a point a piece, 11 points. And then the last four questions don't have a lot of points. And so this is a short one. You'll like that. Um, it says, okay, so some binary compounds that form between fluorine and various nonmetals are listed in the table above. A student examines the data in the table and poses the following hypothesis. The number of fluorine atoms that will bond to a nonmetal is always equal to 8 minus the number of valence electrons in the nonmetal atom. Okay, so let's talk about this. What does that mean? Because sometimes in these questions are hard. It's like my students struggle to figure out what they're asking. So here's the deal. We know if we look at a periodic table that carbon is in group 4A. And so carbon has 4 valence electrons. Nitrogen is in 5A, so it has 5 valence electrons. This is in 6A. And then neon is in 8A because it's a noble gas. And silicon is in the same family as carbon. It's 4A again. And phosphorus is 5A. And sulfur is 6A. And argon again is 8A. It's a noble gas. And so his hypothesis was it's 8 minus the number of valence electrons. So let's think about this. 8 minus 4, because it's in group 4A, is 4. And there is 4 fluorine atoms. And then 8 minus 5, because this is in group 5A, is 3. And notice there's 3. 8 minus 6 is 2. 8 minus 8 is 0. 0 means no. So this is interesting. Notice he's got 4A, 5A, 6A, 8A. So based on the student's hypothesis, what do you think would be the formula of the compound that forms between chlorine and fluorine? And because chlorine is in group 7A, because it's a halogen, 8 minus 7 is 1, so you would expect that it would be ClF1, and we don't have to write down the ones. Look at the pattern up here. 4, 3, 2, it would fit in here. 1, 0, 4, 3, 2. Actually, fluorine fits in here and chlorine fits in here. So that's a pretty easy if you know what it's asking. In an attempt to verify the hypothesis, the student researches the fluoride compounds of the other halogens and finds that there's also a formula called ClF3. And then the next question is draw the Lewis electron dot diagram. So here we go. Here's ORP. So we got, so we put the chlorine in the middle and we put the fluorine around the outside. 3 of them. Sorry, that's not how I taught you to do it in class. I always say evenly spaced because it doesn't really matter. What it looks like in 2 dimensions is not what it looks like in 3, which is why we do all the stuff with those models. So you put the chlorine in the middle and you put the fluorine on the outside, and then the octet rule says that every atom needs to have 8. So this guy has 2, so you got to put 6 dots. And this guy has 2, so you got to put 6 dots. And this guy has 2 and it wants 8, so you got to put 6 dots. And then the chlorine has 2, 4, 6, so you got to put 2 dots. And then when you count 6 and 6 and 6 is 18, 20, 22, 24, 26. And so ORP is 26 electrons. But then VE is 7 plus 7 plus 7 plus 7, because these are all in 7A, which is 28 electrons. And remember, when ORP is less than VE, that means you have too many valence electrons. You have an octet rule expansion, not multiple bonding. Multiple bonding is what happens when you have too few. And so your sketch ends up looking like this. I'll redraw it, but I would not waste your time on the AP exam redrawing it. But you're going to have chlorine with the fluorine around the outside, 3 of them. but, and then these are still going to have 6 dots, and this is still going to have 6 dots, and this is still going to have 6 dots. But instead of this having 2, 4, 6, 8, it's going to have 10. And so this ends up being an AB3, E2, which is a T-shaped molecule. They didn't ask for that. They just asked for the sketch, but I know the next part of the problem that's coming. And so, because remember now, let me just, because part of the thing on the AP exam too is you got to memorize all this stuff. But here's what happens. 2 plus 3 is 5. And so this parent structure is, sorry, I got to grab a pen. This parent structure is what you get. It's a trigonal bipyramidal. So here's the central atom, and then here's the north pole, and then here's the south pole, and then the other 3 go around, and then this one shoots out, and then this one goes back. But then when you empty 2, and I always just empty these 2 for this shape, you can see the letter T. It's T-shaped. Because, you know, what you see when you do X-ray diffraction is you see the atoms, and they're like in the letter T. So, but that one just says, draw the electron dot diagram. And then the next question is, 2 possible shapes for the CLF molecule are trigonal, planar, and T-shaped. Now remember, trigonal planar is AB3, and T-shaped is AB3E2. The student does some research and learns that the molecule has a dipole moment. Now, a dipole moment means, because a dipole moment is a measurement of how polar a molecule is. Dipole moment means that CLF3 is a polar molecule. Okay, which of the 2 shapes is consistent with the fact that it has a dipole moment? And the answer is T-shaped. And the reason is, because it says justify your answer. Remember now, I'm going to switch colors. What do you need to have a polar molecule? 1. You need to have at least 1 polar covalent bond. We actually have 3. And a polar covalent bond on the AP exam is that they have to be different, because they have to have different electronegativity. So we have 1, I'm sorry, here's our picture down here, but same thing. 1, 2, 3 polar covalent bonds. And here's the most important thing. And 2, the bonds, because you can have some molecules like HF that only has 1 bond, must be asymmetrically arranged. You need to have both of those things to have a polar molecule. So then it says justify your answer in terms of bond polarity and molecular structure. And so what happens is, which of the 2 shapes is consistent with the fact that CLF3 has a dipole moment? And the answer is T-shaped. And then your justification is because in order to have a polar covalent, in order to have a polar molecule, you need to have these 2 things. And B3 has symmetry. What happens is those shifts all cancel, and so the molecule does not have a positive side and a negative side. AB3 has symmetry, and if that was the shape, that would be that would result in a nonpolar molecule. And then the last question, which is kind of tricky, based on the concepts of atomic structure and periodicity, propose a modification to the student's previous hypothesis. So now this is kind of interesting, and what I've found is that I am going to call this FF, because notice they all have an FFF at the end, FF. So now a couple things I want you to notice. This is the one that's the highest on the periodic table. This one comes in second, this one comes in third, and this one comes in fourth. And so what happens is, a couple things happen is that when the first halogen has 1 formula, the third has 3, The fourth has 4, so does it make sense that the second would have 2? It would be ClF1, and then probably 135, 1357, this would probably be ClF3. And then this would be, so 1, 1, 3, 1, 3, 5, 1, 3, 5, 7. And so I actually looked at the scoring guidelines, and they just want you to mention something like this. 1, there is always an odd number of fluorine atoms. That's the first thing they want you to notice. And 2, as the atomic number increases, that's generally how we say in chemistry as you move down the table. So this is atomic number 9, 17, 35. As the atomic number increases, the number of compounds increases. That's really all they were looking for. I went in, when I took the practice test, I went into much more detail. I'd say the first halogen has 1 compound, the second one has 2, the third has 3, the fourth has 4. As you go down the family, there's more compounds, but they just want you to know there's always an odd number of fluorine, and as the atomic number increases, the number of compound increases. If you had both of those, you got full credit.